This is the OHMni-Stick, my entry for the 2023 Hackaday Prize. When Hackaday announced they were bringing back the Assistive Technology Challenge for the 10th year of the prize, I got started right away. I remembered the lessons I've learned from advisors along the way to focus on affordability, durability, and making it sufficiently sensitive. The OHMni-Stick enhances users' ability to interact with technology, particularly those with diminished muscle strength and limited dexterity. Here is the first version. It uses 3 load cell force sensors to detect motion. It uses commodity, very affordable parts. You can see how they're arranged under the plexiglass inside of this simple 3D printed enclosure. I designed, fabricated, and built this in just one day and was shocked at how well it worked. So I moved on to improving it. Through the months, here's what I've managed to do. This is the latest and greatest model, just built yesterday. If you go to the bottom of my Hackaday page, you can see the build video. Of course, all of the open source design files are available on the page. You're free to build one yourself, and I'm glad to provide help if you need it. I want to move on to the attachments, but the core device is just this. The force sensing module. And it can detect not only XY motion, like a mouse or trackpad, but also Z, like pushing or pulling. Right now, this is not used, but it's untapped potential for the device. The first attachments that I came up with are these magnetically swappable grips. Depending on the context, people may desire different grips. This one is similar to those used for a power chair. Or this one, I prefer for drawing. Or this one helps to hold your hand in place if you're experiencing tremors. I've designed the 3D models so you can adjust them to your own needs and measurements. If you think of other grip shapes, please let me know. I'm glad to incorporate them. Next was the challenge to develop the buttons. At first, I used capacitive touch buttons, which you can see here, but I found this wouldn't work for everyone. Leading to the next idea. I was familiar with the idea of soft robotics, and this option features silicone pillows, which use a small pressure sensor beneath each one. The pressure sensor allows you to adjust the exact amount of pressure that you have to apply for the device to register it as a click. The most recent attachment that I've come up with is this sip and puff mouth-operated so-called grip for those who may not be able to use their hands. One of the most vital features of this device is that you can adjust the sensitivity across an incredible range to the point that it can actually measure the force of a feather while also handling extreme pressures. Even if you bump it, hit it, whatever, it won't cause damage to the user or the internal mechanism. Most devices on the market seem quite prone to damage, which is why the magnetic detachable grip is an important feature. Of course, this video should demonstrate the OHMni-Stick in action. The firmware is written so that it should work on any device, Mac, Windows, Android, iPhone, Linux, whatever. Here, I have it hooked up to an iPad using a commonly available USB adapter. I'm gonna swap on the standard grip. Let's head to the project page. Right now, I have this button set up as the right click, this one is the left or context, and the leftmost one enables scrolling. However, in the firmware, you can change these to whatever buttons or functions you want, including macros. So, just to show off, I'll swap to my favorite grip and then draw something for you. Anecdotally, I had my wife's arthritic 98-year-old grandma give this a try. While she was highly suspicious of technology, she was able to make it work and was quite proud of her efforts. So, that's a win. That's the summary. Check out the details on hackaday.io and download the files, adopt it to your uses, and give me any ideas you have. I'm relying on you, my fellow makers, developers, and users to bring the OHMni-Stick to those who will benefit. Thanks for watching.